Hi all, welcome back to my lecture series. This is Muthuminal R, Assistant Professor from the Department of Agricultural Engineering at SNS College of Technology. Today let us see the topic on duty delta, base period and the factors that are affecting duty under the unit crop water requirement under the subject Irrigation and Drainage Engineering for the students of third year 6th semester. In today's lecture, we shall discuss these important concepts in irrigation engineering, that is duty delta and base period along with its factors. These concepts are fundamental because they help the engineers to estimate crop water requirements and design efficient irrigation system. So before going into the session, let us have a small recap what we have seen previously. We have seen some concepts such as crop seasons, the methods of irrigation, classification based on the command area. All these concepts are interrelated and form the basis for irrigation planning. So let us start with an important question today. Suppose we have a fixed quantity of water. If it is available in a limited constant fixed quantity, what happens now? How do we determine the area that can be irrigated, whether the available water is sufficient for crop growth? So the answer lies in the concepts of duty, delta and base period. Let us understand duty first. Duty is defined as the area of land that can be irrigated with 1 cubic meter per second of continuous water supply during the entire crop period. In simple term, duty indicates the efficiency with which the irrigation water is utilized. So that means, for an example, if 1 cubic of water irrigates 2000 hectares, the duty is said to be 2000 hectares per cubic. A higher duty means that water is being utilized more efficiently, whereas a lower duty indicates greater water requirement. So now let us discuss about delta. Delta refers to the crop water total depth of water required by a crop throughout its growing period. It is expressed in centimeters or meters so that the different crops have different duty values. For example, a paddy requires a larger quantity of water and therefore has a higher delta, whereas pulses and oil seeds require comparatively less water. Now let us move on to the base period. Base period is defined as the time interval between the first irrigation and last irrigation of a crop. In other words, it represents the total duration during which the irrigation water is supplied to its crop. Different crops have different base periods depending upon their growth and depending upon their growth duration and also the climatic condition. These three parameters are closely related because if the base period increases, the duty and the water requirement also changes. Similarly, a crop with higher data and higher delta will require a greater volume of water. So the engineers use this relationship among these parameters while designing reservoirs and canal system. Now let us understand this through the example shown in the slide. So consider a mustard crop having a base period of 120 days and a delta of 40 centimeters. That means a continuous flow of 1 cubic meter per second for 120 days provides approximately 10.368 million cubic meter of water. So since each hectare requires about 4000 cubic meters of water, this quantity of water can irrigate nearly 2592 hectares. So this value represents the duty of the water. Now let us discuss the factors affecting duty. Several factors influence duty. The type of crop is one of the most important factors because different crops have different water requirements. Climate also plays a major role. High temperatures and strong winds increase evaporation losses and reduces the duty. Soil characteristics affect water retention. Sandy soils require frequent irrigation while the clayey soil retain moisture for longer duration. Rainfall, cultivation practices, topography and irrigation methods also influence duty. So the modern irrigation methods like drip irrigation improve water use efficiency and increases the duty. So, hence, understanding duty, delta, and base period is essential for effective water management and sustainable agricultural production. So, this is the summarization that we have seen today. If you guys have any kind of doubt or anything, you guys can ping me anytime. See you at the next class. Thank you.